Let's draw the Fischer projection of this one. How many stereocenters do you see? We have a 1, 2, 3. Is that a stereocenter? Any of the sp2 hydrogen polygon is not a stereocenter, right? The carboxylic acid polygon obviously has a 2 oxygen there, but they are differently bonded, one with a double bond or the single bond, but that's an sp2 hydrogen. So that's why that is not a stereocenter. And then this methyl in the end of the chain has a 3 hydrogen, right? Anytime you got more than one copies of the same thing there, then that becomes asymmetric and not the symmetrical one. So that's not stereocenter polygon. The total of the stereocenter here is 1, 2, 3. So how we should draw the Fischer projections? The big vertical line and 3 horizontal line, right? That's basically what we should do. Now the question is, what we should put on the top, what we should put on the bottom. That set the perspective. How we going to look at the ring. I mean, you can do either way. I mean, there are carboxylic acid and methyl. You can put the carboxylic acid top. You can put the methyl groups on top. You can do either way. It really doesn't matter. But more followed convention is the carbon with a more oxidative state. They go to the top. There's a carboxylic acid and a 2 oxygen there. Methyl groups has a 3 hydrogens. You can easily see that the carboxylic acid becomes a more oxidized forms. So more conventionally, you put the carboxylic acid on top and the methyl goes bottom. But either is fine. Once you do that, now you see how we're going to look at the molecule. This one, this stereocenter, with the hydrogen shown there, how are we going to look at the molecule? We have to make all the vertical line coming toward you, the horizontal line coming toward you, and the vertical line going against you. Only way to get the view is you lie down on the floor and looking up, but your feet in that direction because we put the back on the bottom, and then head is where the carboxylic acid, right? That sets, I mean, this putting one in the top or in the bottom, set the perspective. So when you lie down on the floor, looking up, now we see hydroxyl groups coming out the screen, right? That's on my left-hand side. So where should the hydroxyl groups go? That's the right-hand side. That's the left side. You see the so looking down here, hydrogen left side. This left side, the left-hand side, and the hydrogen side here. So we do that for this stereocenter. Now the middle one. If you look at the same direction, then these 2 vertical line is coming toward you. So that's not the right direction to see the molecule. You have to look at the molecule, dangling on the ceiling, looking down. Why we change the perspective? Because of these 2 vertical line should go away from you. That's the convention of the Fischer projection, right? That's why we are changing the perspective, depending on which stereocenter we are looking at. This is the only way we can make these 2 bonds in the vertical goes away from you. And then now these 2 horizontal line, dash means behind the screen. And I'm looking down, right? Dash is behind the screen, that's on my left-hand side. So where the methyl has to be placed, my left-hand side. And the hydrogen on the opposite side. Now the next one. This one, for the same reason, you cannot look at the carbons from the same direction because if you look at from the ceiling, these 2 lines is coming toward you, which is not the convention. So now we have to lie down on the floor again. That's the only way you make these 2 vertical lines goes away from you, right? And then you got the bromine here, you got the hydrogen there. Now you lie down that way. You know, it's kind of hard to do that here, but imagine you're lying down on the floor hand is here, fin is that direction. Bromine is behind the screen, right? Behind the screen. That is my right hand side. So where the bromine has to appear, my right hand side. You can easily see that many mistakes can be made. That requires a lot of practice at home. Challenge each other. That would be, I think, very good. But as I said again, once you draw, if you want to be sure that's the right drawing, you assign absolute configuration, and that has to be matched. And that with this one with that one. If you do that, then you can double check whether you were drawing is right or wrong, regardless of your drawing skill. I highly suggest it. Then how to draw this one? The question go back to again. How many stereocenters do you see? Not 5, right? You have a 2 stereocenter, those 2. So 3 stereocenter, I got the 3 horizontal line, 2 stereocenter. So should I do this? That makes sense, right? I got 2 stereocenters, so 2 horizontal line and 1 vertical line. But if you do that, there's something that you're missing, which is that CH2. That CH2 is there, not the bond these two are put together. This CH2 here. So that's not the right one. Then what about this way? I got 1 stereocenter, put the CH2 there, and another stereocenter. Does it make sense to you? That is not the right way again either. So what we're gonna do, we draw same 3 vertical line because of this the 1, 2, 3 formats here. We show them as a block, not individual. But the middle one is going to be hydrogen, hydrogen. But it has to be known. If you miss that one like this, then it will be 1 format short of a liquid. Now, after you do that, same question. What goes top, what goes bottom? That basically set the direction perspective. Again, it's totally up to you. You'll get the 180 degree rotation, think it, and choose it the other way. But as I said, my convention is the more oxidized carbon goes to the top. And then that's just methyl groups, that's a CH2OH. And you could potentially do that way, but that's not normally what the Fischer pressure does. You have to use a condensed fluid mode. So the CH2OH, this thing goes top, methyl on the bottom. Now, the first one we're going to do, we have to do that to make these 2 vertical lines go against you. You have to look at from the ceiling, right? Head is in that direction, feet is in that direction because we decided to put it this way. And then now you look at there's a fluorine and hydrogen as substituents. Fluorine is coming out of the screen, right? That is on my right-hand side. So where the fluorine goes, left-hand side, right-hand side, fluorine goes to the right-hand side because it's coming out of the screen. And the next one is an easy because it's H2, so it's H8. So that's what we're talking about. Even though that's not the stereocenter, you have to put it there. You just have to pick the same substituents. For the next one, we have to pick the same perspective looking down, or do we have to lie down the floor looking up for that stereocenter? The goal is to make this vertical line go against you or away from you. So you have to look from the ceiling, looking down, same directions. You got the OH coming out of the screen, that is still on your right-hand side. So OH goes here, hydrogen goes there. So that is what you need to do to draw the Fischer projections.